In this lesson, we're going to look at how to simplify radicals when they are in the denominator. So for a radical to be in simplest form, you technically cannot have radicals left in your denominator. So the radicand in the numerator must be simplified, but also you cannot leave a radical in your denominator. So for example, the square root of 12 divided by the square root of 50 is fully simplified as the square root of 6 over 5. So today we're going to learn how to go from here to there using some simplifying processes. So to eliminate the radical in the denominator, what we're going to do is multiply both the denominator and numerator by the radical. And this is called rationalizing the denominator, getting rid of the radical in the denominator. So what we will do is start by multiplying the square root of 5 over the square root of 10 by whatever radical is down here in the denominator, which is the square root of 10. When we do this, we're going to multiply both the top and the bottom by square root of 10. The only reason we are allowed to do this is because the square root of 10 divided by the square root of 10 is 1. Anything divided by itself is 1, so because we're just multiplying this fraction by an expression equivalent to 1, we're allowed to do this. It's not changing the value of anything. So up top, multiplying fractions is no problem. We go top times top and bottom times bottom. Up top, we get the square root of 5 times the square root of 10 as the square root of 50. On the bottom, the square root of 10 times the square root of 10 is the square root of 100, which hopefully you recognize as a perfect square. This will always happen simplifying to just 10. Okay, so, essentially you can really skip this step because you know that square root of 10 times square root of 10 will just be 10 without the radical. But this proves why right here. Now up top, we do need to now simplify. So our square root of 50 can break apart into 25 times 2. The square root of 25 will come out as a 5, leaving us with the root 2 underneath and the 10 down below. Now, because this is multiplication, if you've got a number out here and a number in the bottom that share a common factor, like 5 and 10, share a common factor of 5, then you can further simplify. So if you want to see this written a different way, oops, and I actually just rewrote it the same way, then what you can think of this as the square root of, or 5 over 10 times the square root of 2 over 1 to really clearly see that 5/10 will further simplify to 1/2. So the final simplified expression for root 5 over root 10 is root 2 over 2 because the 5 and the 10 divide to be 1/2. And you can have this 1 here or you can leave it off. It doesn't make a difference. All right, so let's take a look at another example practicing this. So here we have the square root of 3 over the square root of 8, and we want to get that radical out of our denominator. So whatever radical's down there, we're going to multiply both top and bottom by that. So that means in this case, we're multiplying numerator and denominator by the square root of 8. So square root of 8 over square root of 8. So up top, the square root of 3 times the square root of 8 will give us the square root of 24. And on the bottom, this should simplify just to an 8. Finish by simplifying your numerator. So 24 breaks into perfect squares or a perfect square factor of 4 times 6. The square root of 4 will come out of the radical as a 2, giving us 2 root 6 over 8. And 2 divided by 8, these reduce to be a 1/4. They can both divide by 2. Woo! Come back here. There we go. So we are left with root 6 over 4 as our final simplified expression for root 3 over root 8. For this one, we've got the square root of 2 in the denominator. If you want to try this on your own, go ahead, click pause, and then click play when you're ready to check, but I'll just continue on if you still want to see another one worked out. So square root of 2, we need to multiply on top and bottom to get rid of this radical in the denominator. Up top, your square root of 7 and square root of 2 can multiply to be the square root of 14. And the 5 has to stay out front because, there's technically a 1 here, but it can't go under your radical. It needs to stay outside like it started. And for this problem, that is as far as we can go because there is no square root of 14 that can break down any further. And 5 and 2 don't reduce, so we're done. Okay. In this example, we've got the square root of 6 over 4 times the square root of x. Now, it's okay for us to have numbers in our denominator. What's not okay is for radicals to be in the denominator. So to get rid of the radical in the denominator, you only need to multiply by the square root of x over the square root of x. Once you've done that, you will be left with, up top, 6 times x under a radical, and the square root of x times the square root of x is the square root of x squared. This simplifies to just a 4x on the bottom. Square root of 6 cannot further break apart under that radical as a perfect square factor in any way, nor can the x to the first. So here we are finished, and we've gotten rid of the radical that was in the denominator. All right, so for this example, you could do the same thing we just saw in the last one and just multiply the top and the bottom by the square root of 12. However, I'm going to show you that I'm going to only multiply the top and bottom by the square root of 3. And there is a reason why I'm going to use just the square root of 3. Like I just said, if you multiply by the square root of 12 on top and bottom to get rid of that radical, you are completely correct. It will give you some slightly larger numbers, but if you can see that 12 times 3 produces a perfect square. So there's a perfect square much smaller than 12 times 12, which would be 144. Then this will reduce in the amount of some of the simplifying you would have to do at the end. So I'm just choosing 3 because I'm anticipating or looking ahead and seeing that 12 times 3 will give me a perfect square here that will simplify with just some smaller numbers. And remember, you can choose anything you're multiplying top and bottom by as long as it's consistent, because that value for that fraction is 1. So up top, 4 root 3 times root 3 gives us 4 times root 9. On bottom, 5 times 12 times root 3 is 5 times the square root of 36. So this is a clean, perfect square of 3 that will come out, and this one comes out as a 6, meaning both of these are cleanly taken to give us a 12 over 30, which reduces to 2/5. So, just to show, oh, I already went over this. Anyways, so like I said, if you wanted to have done the square root of 12 over square root of 12, you still would have gotten the exact same final answer as us. You probably just would have had bigger numbers to simplify along the way, and that's totally fine. All right, so let's move on to radicals that have binomials in their denominators. So if the radical in the denominator is a binomial, you should multiply by the conjugate of the denominator. So radical conjugates, for example, look very similar. So this binomial is a conjugate of this one and vice versa. And what you'll notice is that in the binomials, the two parts of the binomials are the same, but the signs are opposites of each other. So binomials in the form of p root q plus r root s or p root q minus r root s are called conjugates. And they are useful because if p, q, r, and s, so whatever these numbers are rational, then the product of their two conjugates will be a rational number. So what this means is that when we multiply these expressions together, we will not get a square root in our answer. We will not have any expression left under a radical, which is going to be really convenient for getting rid of radicals in the denominator. So we're using really the idea of difference of squares here, which we saw in our factoring unit earlier this year, where if we multiply these out, 3 times 3 is 9. 3 times negative root 2 is negative 3 root 2. 3 times positive root 2 is positive or plus 3 root 2, and root 2 times negative root 2 is the square root of 4, negative. And so this is going to be a perfect square that can simplify. And then here we've got negative 3 root 2 plus 3 root 2 that go away and become 0. So, oops, and so the square root of 4 is 2, meaning that we're really just going to get 9 minus 2, which is 7. So this crazy, two binomials being multiplied with square roots all simplifies to just 7, which is really nice. The radical terms always cancel out in the middle. So let's practice writing conjugates first, and then we'll use them. So to write a conjugate, just copy the binomial exactly as is, as you see it, in the same order, but just switch the sign in the middle from addition to subtraction or vice versa. So here's our first example. Let's write the conjugate for negative 2 plus root 7. So its conjugate will look exactly the same, but you just change the addition to subtraction. The square root of 10 minus the square root of 3. We'll copy the parts, but change subtraction now to addition. And here we have 4 plus the square root of x, so its conjugate is 4 minus the square root of x. Okay, so let's use this. So here we have 9 divided by the square root of 8 plus 7. Because of this addition, we're going to need to multiply by its conjugate in the denominator to get rid of that square root of x. We can't just multiply top and bottom by the square root of 8. That would result in us needing to distribute the square root of 8, and our 7 would be then left with the square root of 8. So it's really not getting rid of a radical unless you use a conjugate. So the conjugate of root 8 plus 7 is root 8 minus 7. And again, you multiply top and bottom by this exact same expression because anything divided by itself is 1. That's why we're allowed to do this. From here, 9 multiplies to root 8 and to negative 7. And on the bottom, square root of 8 times square root of 8 is just 8. And you can stretch this out the long way to get minus 7 root 8 plus 7 root 8, but those will cancel each other out. And then a 7 times negative 7 is negative 49. So another way to look at it is, like I just said, square root of 8 times square root of 8 is 8. And up top, 9 root 8 minus 63. And this is 8 minus 49, which simplifies to a negative 41. Up top, your square root of 8 can break down into 4 times 2. So remember, we always simplify radicals as far as they can go, meaning that this portion of your numerator becomes 18 root 2 minus 63 over negative 41. In this problem, we are finished at this point. If, however, the coefficients and numbers in all 3 chunks or parts here could divide out by a common factor, then we would simplify all 3 parts or pieces here. And I mean the pieces separated by addition, subtraction, and that division bar. In this case, none of them share any factors, so we're done. All right, so here's our next one. We have a conjugate, or we need a conjugate in the denominator, so we're going to multiply by 5 plus root 6. Now up top, we've got 2 binomials multiplied together, so that's going to be quite a bit of stretching out there. On the bottom, same thing, 5 times 5 is 25. The middle terms will cancel out, and negative root 6 times root 6 is negative square root of 36, which is really just 6. So stretch out your top to get negative 15 minus 3 root 6 plus 5 root 3 plus the square root of 18. At this point, you're going to simplify any radicands that you can. So this square root of 18 will break to a 9 times 2, meaning this comes out as a 3. So that portion will be a 3 root 2. And 25 minus 6 in the denominator is 19. Again, do check to see if every piece separated by addition and subtraction shares a common factor. So I'm looking at 15, 3, 5, 3, and 19. They do not, so we cannot simplify further. We are finished. All right, and here's our last example for this lesson. So I'll let you try this one out on your own, and we'll check it together. So click pause, and when you're ready to check, click play. Okay, so the conjugate you should have used should have been negative 10 minus root 8, which would give a 100 minus the square root of 64, just 100 minus 8 on the bottom, which is 92. And up top, you've got quite a bit of stretching out to do, multiplying those two binomials. And then from there, the square root of 48 simplifies and the square root of 24 simplifies. So this one is 16 times 3. This one breaks to a 4 times 6. So that 4 comes out as a 2. This 16 comes out as a 4, giving us the 4 root 3 and the 2 root 6 there. Now the negative 10 root 6 and 10 root 3 can't go any further. However, at this point, notice that in the numerator there are some like terms that can combine because they have the exact same radicands. So the negative 10 root 6 will combine with the plus 2 root 6 to give a negative 8 root 6. And then over here, the negative 4 root 3 combines with the plus 10 root 3 to give a plus 6 root 3 up top. And finally, if you notice your three chunks in this expression, so the three pieces separated by addition, subtraction, and the division bar, all share a common factor of 2. So I can divide a 2 out of negative 8, out of 6, and out of 92. And you only do this for things outside the radicals. And because we can do that, this fully simplifies to negative 4 root 6 plus 3 root 3 over 46. And that's your final answer. So that one was a little more involved than some of the others, but that will bring us to the end of our lesson for today.